Alright, so in this video we're talking about graphing and solving systems of linear inequalities. Now, in the previous videos we talked about graphing and solving linear equalities where we're maintaining the balance on our seesaw. We're talking about inequalities now, so our seesaw is out of whack. Alright, so here, what's a system of inequalities? Well, first off, our inequalities that we're looking at are in two variables. So we're looking at two or more inequalities that are in two variables. Two or more variables, I should say. And what does the solution look like? Well, essentially what we're going to do, the solution are any points, ordered pairs, so these are ordered pairs. Ordered pairs that satisfy every inequality in the system. Okay, so that's satisfied each inequality in the system. And then how do we graph a system of linear inequalities? Well, we're going to use the grid. Okay, we're going to use the grid, and we're looking for we're going to graph the boundary lines just like we do when we're just looking at one linear inequality. But now we're going to shade every linear inequality in our system, and we're looking for the overlap of the shaded region. So we're graph the boundary lines, just like before. Shade, just like before. And now we're looking for the overlap of shaded regions. Okay, so let's go ahead and do an example. Pretty easy one to start off with. So here we want to graph each one of these linear inequalities. We're going to take one at a time. That's the key. Do one at a time, baby steps. Graph and shade one at a time first. So let's do the top one. Okay, you want to do the top one in red. First off, I know it's greater than or equal to. That means my boundary line is going to be solid. I know that for this inequality, the boundary line has a y-intercept of -1 and has a slope of -3. So I could go up 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. So somewhere up here. And then down 3, right 1. 1, 2, 3, right 1. Okay, so my boundary line should be solid. And it should go through those points as best as we can. Okay, try to do a little bit better. So something sort of like that. Okay, and we want to shade. Well, we do this by picking a test point. So obviously, 0, 0 does not sit on the boundary line, so I could use that as a test point. So I'm going to test 0, 0. That just means everywhere for this top inequality, everywhere I see an x, I'm going to plug in a 0. Everywhere I see a y, I'm going to plug in a 0. So let's do that. So I have 0 is greater than or equal to 0 minus 1, which means 0 is greater than or equal to -1. Which is true, so I'm going to shade on this side of the line, this side of the boundary line. So all of these points on this half plane will satisfy the top inequality. Okay, no big deal. Now let's graph the second inequality. Now first off, I have y is less than x plus 2, so that means my boundary line is going to be dotted, not included in the solution. And it has a y-intercept of 2. And a slope of +1. So up 1, right 1, up 1, right 1, down 1, left 1, etc. Okay, so now that we have several points, remember this is a dotted line. So it should be dotted. We need to pick a test point. So I'm going to pick 0, 0 again. Test that point. Everywhere I see an x, we'll put in a 0. Everywhere I see a y, I want to put in a 0. So I have 0 is less than 0 plus 2. 0 is less than 2, which Obviously that's true, so I'm going to shade everywhere below the boundary line. And so my solution for this system are all the points that satisfy both. In other words, I'm looking at this overlap area right in here. Okay, that's the graph of the solution. I'm not looking for just red or just blue. I want both. Okay, to solve the system inequalities, both have to be shaded. So any point over here that's shaded in both red and blue, that's a solution to this system of linear inequalities. Okay, graph the system, a little bit more complicated. So here in this system we have 3 inequalities we need to take care of. Take it one at a time. So I'm going to do the first one in red. X greater than or equal to a number. So first I know that my boundary line's solid, and also I have X and a number. Well, that means that this boundary line is going to be a vertical line. Okay, and I'm just going to write out vertical like we did in the previous chapter just to help keep me on track of what I'm supposed to do. So X goes through 0, and it's a solid line. So it actually turns out just to be the y-axis. Okay, well I need to shade. Well, that's pretty easy. X less than 0. So anything less than 0 for my X values. So -1 is less than 0. So I'm going to shade on the left-hand side of this boundary line. Or actually, sorry, I read that wrong. It's X greater than or equal to 0. That's my fault, sorry. So X is greater than or equal to 0. So that's actually on this side of the boundary line. So all of these points over here are greater than, or X greater than 0. Greater than or equal to 0, that is. Okay? All right, so now we're done with that one. So let's go ahead and graph the next one. So y is greater than or equal to 0. So again, we know our boundary line is going to be solid. And we also know that our boundary line is just simply a horizontal line, because it's just y and a number. And it turns out it's just the x-axis. So it's just going all the way across. And it's a solid line. And it says y greater than 0. Well, +1 is greater than 0, +6 is greater than 0. So anything above this boundary line satisfies that inequality. So all those points satisfy that inequality. Okay, now we need to take care of the last inequality. Okay, I'm going to do that one in green. Well, obviously that's not going to be horizontal or vertical. It's going to be some kind of diagonal line. And it would probably be best if we just get y by itself. So let's do a little bit of scratch work first. So I have 3y, and I'm just going to use equals for now. Actually, let's use the inequality just in case. So 3y is less than or equal to -4x plus 24. Divide by 3 on both sides, so I have y less than or equal to -4/3 x plus 8. Alright, so plus 8 is my y-intercept. I know my boundary lines will be solid, and my slope tells me to go down 4 units and right 3 units. So 1, 2, 3, 4, right 3 units. So 1, 2, 3. Down 4 units, 1, 2, 3, 4. Right 3 units, 1, 2, 3. And it's a solid line. So just connect the dots as best as you can in a straight line. Okay, so something like that. Now, its y is less than that, so we want to test the point. Well, obviously 0, 0 does not lie on our Greek boundary line, so I can test it. 0, 0. So everywhere I see an x, I want to put in a 0, and everywhere I see a y, I want to put in a 0. So let's test that point. So I have 0 is less than or equal to 0 plus 8, or 0 is less than or equal to 8, which is true. So I know I shade on this side of the boundary line for my green. Yeah, well, that might be a little hard to see, but what we have now is a really nice triangle. So I'm just going to erase the other shading, the shading that is not part of our solution. I'm going to do my best to erase it nicely without messing up my entire picture. Okay, now, you know, but you get the idea. So after doing a little bit of erasing, and you can do this on your paper as well, you can clearly see that, hey, I've got my boundary lines. Okay, something like that. So my solution is just this triangle that I've drawn. Remember, this was a solid line. My solution is this triangle that's got all three colors in it. All three colors. It's got the red, it's got the blue, and it's got the green. Any point inside this triangle right here that I've created will satisfy all three inequalities. And that's it for graphing and solving linear inequalities. Thank you.